Hello YouTube. We're going to talk about other variable types today, including primitive variable types such as double and float. But before we talk about that, we should have a slight recap of what we previously talked about in the previous video. So we have string, right? And the concept of a string is pretty straightforward. I mean, you have text, right? You have letters, numbers, space, symbols, all that strung together is a string. So that's what a string is. And you define what a string variable is equal to with a set of quotations. And that lets the compiler know this is a string. So I can make a string equal to a name or to a paragraph or a lot more text. It's really just dependent on my use case. Strings are very useful. In this case, So if you want to add a character or multiple characters or just another string entirely to a current string, you can do name of string equals string plus either the information you want to add in quotations or the other variable. You could do that too. And here I just printed it out. Wally I. You can also use string methods because string is a class type instead of a primitive type. You can access these various methods for handling strings. So for example, this one, to uppercase, does what you imagine it to. It converts the entire string to uppercase letters. So you can hover over class types and you'll see like information about the class, such as string. You can see like it's part of java.lang package. It's one of those default packages that you do not have to import, unlike java.util.scanner. Now here is an int. Int stands for integer. So int stands for integer, and integers are whole numbers. Whole numbers have no decimal part. They have no decimal point, right? In fact, actually, if you try to give a variable specified as an int a decimal value, you will get an error. It'll say, hey, you can't do that. So we have ourselves an integer called y that equals 8. If we want to have like a mathematical expression, we could say like int x equals y times 9, right? So the way you do multiplication is to write an asterisk, and we could output the value then of x. So we got 72. Now if we do division, you're going to notice something kind of interesting. With some numbers, if you perform division between integers, the result must also be an integer, right? Well, that causes problems because what if it doesn't divide cleanly? Now I have to introduce to you the double data type. Now, what double is? Double means that it has a decimal part, that has decimal points, that it can have decimal points. If I tried like 8.0 or 8.1 or 8.2 or whatever for an integer, it will complain. It'll be like, no, you can't do that. But if I have double, then it's okay. And it results in a very different output, right? So, should you use double all the time? I mean, it's dependent on what you're using it for, but yeah, you should use double over integer when you need the decimal portion. There's also something called float, which is very similar to double, except that when you define a floating point variable, a variable of type float, you have to put an f after it so it doesn't get confused with a double. Because if you don't put an f, it assumes you're trying to assign this variable of u of type float a double value instead of a float value, which is why it complains right there. You put f, then it knows what you're talking about. Now let's say we want to add a new value, or let's say we want to increment whatever this is. So this is x is equal to 0. What if we just want to add 1 to it? You say x is x plus 1. That's one way. What that means is x is equal to x plus 1. You can't simply say x plus 1 because work. It's like, what? But if we can say x equals x plus 1, we could also say x plus equals 1, which means the same thing. We could also say x plus plus, which literally just means add 1 to x. Okay. In fact, there's that. We can try a bunch of other things. We can try, for example, we can use these numerical data types, these numerical variables for if statements, for example. Like, let's say I have two numbers of type double. Num1 is equal to 0, and num2 that is equal to 0. And let's say I change the values of those numbers by using a scanner. Num1 equals scanner dot x double, and num2 equals scanner dot x double. So as you can imagine, what we're asking here from the user is to, hey, give us a value for num1. That is a double. Give us the next double. And give us a value for num2. That is a double. We can also like spell that out for the user so that they know they're supposed to write some numbers. Please give two. Please write two. Then we can say that x, double x is equal to num1 divided by num2. So what this means is, hey, we're giving num1 and num2 values, and then we're going to divide those values by each other to give us x. And then we'll print out x. So let's do that. All right, let's put in 8.2 and 9.93. And then we get this. This is the result. Very cool. Now, it's a little interesting. So when I press enter, it prompted me again, but it didn't say to do anything. So make this program easier to use, we can say system.out.println again, and then say, please enter a number for num2. So now, when we do this, please give num1. That's a really weird question. Please enter a number for num2. And now it divides them. Now, there's one issue that we need to consider. What if the second number is a 0? We're dividing, after all. What happens if you divide by 0 in Java? Well, we'll find out, right? So we'll run. So 87.4, and then the second number can be 0. It writes infinity. That's a problem, isn't it? It could cause problems because infinity is not a number. Infinity is an idea. It's a concept. You can't do anything infinity except you can print it out, I suppose. You can assign it to things, but it's a problem because, like, what if you need to, like, what if you were like messing with something important and It's like, oh, how much money do you want to add to this person's account? Infinity? Okay, that's not going to work. That's horrible. You don't want to do that. So we have to account for the fact that the second number might be 0. This is where if statements come into place. So we're going to break this up a little. We're going to say double x, and then we're going to define x down here, semicolon here. So it knows that there's going to be a variable called x, but it hasn't been defined yet. We define it down as a separate step. Allows us to make if statement, right? So what is an if statement? An if statement allows us to test to see if something is equal to something of a certain condition. So we can test a condition. So if x, if num2 is equal to 0, then cannot divide by 0. Right? So what this is if num2 is equal to 0, then we write a message, cannot divide by 0. Then what happens? Then it does it anyway. Oops, we don't want that. So if it is not equal to 0, let's put this code in here, right? So what will happen is if num2 is equal to 0, it will say this. Otherwise, in all other situations, it will perform the operation and print out its value. So that's what the else block does. We know what's in the else block because we have an opening curly bracket and a closing one. And we know what it does if it is true that num2 is equal to 0 because we have an opening curly bracket and a closing one. So this is the body of, if it's true, and this is the body if it's false. Okay. Give 1. Okay, and then if as you can see, it didn't affect normal operation. And if I put 9 and then 0, it'll tell us cannot divide by 0. Okay. What else can we do? We can have if statements. Well, actually, before I show you this, I have to explain something. So you may have noticed there's a difference. There's a num2 equals 0. Then down here there's x equals 1 equal sign, and then this mathematical function. What is the difference between double equals and 1 equals? Double equals is like a comparison. We're comparing this, doing a comparison. Is num2 equal to 0? That's what this means, right? Whereas the single equals is assignment. So when we say something single equals something else, that means that thing is now equal to that thing. Whereas with this, it's like a question. Is num2 equal to 0? That's the distinction. Now, create another if statement here. We can say, is num1 greater than num2? And if it is, we can say, yes, it is. Else, if num1 is less than num2, we can say, no, it is not. And if they're actually of equal value, we can write num1 equals num2. And we can say no. They are equal. Let's try this out a little. So let's write num1. Let's write 1, and then the other one 1. No, they're equal. It will say. Now what happens? 7 and 2. So it is yes. It says yes, but we don't know why it says yes. Well, it says yes because num1 is greater than num. We should specify that's what. we can write this stuff out to be more clear to the user. No, it is not the case that num1 is greater than whatever operation. So thus far, we've been doing all of this inside the main function, the main method, and we'll go over what methods are in the next video, but thus far we've gone over variables in greater detail. We've talked a little bit about the difference between primitives and class variables, and we talked about what a type is. We talked about if statements, and I hope you stay tuned in the next episode where we talk about functions and methods. And then after that, we'll talk about objects and creating classes. But